The flow efficiency chart is a valuable tool for understanding process performance, and it's a particularly powerful metric that helps teams understand how much of their process time is spent actively working on items versus time spent idle. The aim of the chart is to enable teams to identify bottlenecks and optimize their workflow for better delivery, predictability, and value. Flow efficiency calculates the percentage of time that work items are actively being worked on compared to their total cycle time. For example, if a task spends 2 days being worked on and 8 days waiting, its flow efficiency is 20%. This is then shown on the chart with the horizontal axis displaying the flow efficiency percentage and the vertical axis displaying the number of work items. Each bar represents the amount of work items that match that percentage of flow efficiency. To calculate flow efficiency, the chart needs you to either designate which stages in your workflow are queuing, idle, or waiting stages, and/or utilize the blocked function in a way that is compatible with the tool, so it can weigh the time your item spent idle versus active. A recommended practice for board design is to use verbs for columns representing active work. You can even break down your active columns into doing and done subcolumns, as shown by the example data, to visually separate active work from waiting periods. To include time spent blocked, simply select the blocked days checkbox. By differentiating between time spent active versus idle, the tool can help you determine whether workflow issues stem from prolonged waiting times or inefficiencies during active phases. If you do not have a compatible workflow and/or method of blocking work, the flow efficiency chart will not provide any value to you. You can choose to include work items that had a cycle time of 1 day or less in your flow efficiency calculation by selecting the corresponding checkbox. If you would like to exclude them, keep it unchecked. In the same vein, you can also choose to include work items that have spent their entire life in idle states, so items that have 0% flow efficiency in your flow efficiency calculation by selecting the corresponding checkbox. If you would like to exclude them, keep it unchecked. Now that the calculations have been configured, it's time to filter. Using the item filter, you can pick any of the attributes or fields that you brought in during the data loading process to focus your analysis. Using other controls on the chart, you can also drill down not just by your data attributes, but also by different metrics like the workflow stages. Very useful if you wish to analyze smaller portions of your workflow's flow efficiency. You just need to keep in mind to not remove all of your queuing stages, if that's what you're using for the flow efficiency calculation. You can also use the date range in the controls under all charts, or the selected data chart located at the bottom of the chart to analyze data from specific periods of time. Interpreting the chart may seem simple. High flow efficiency means most of the time is spent actively working. You think, great, no need to dig deeper. Low flow efficiency indicates a lot of waiting or blocked time, and thus we need to take action and investigate the possible causes. However, there are some caveats users should be aware of when using the chart. Flow efficiency is an attractive metric that, at first glance, seems incredibly powerful. However, it is also circumstantial and easily manipulated. Your team could have steady throughput and a low cycle time, but if they're not prudently moving their work items from one workflow stage to another when they're finished, or remembering to remove the blocked flag when needed, then that could give false signals of idling and give the impression that they have low flow efficiency. On the other hand, they could have sky-high cycle time and very low throughput, but if they leave their work items in active stages and avoid waiting ones, or never block their work when needed, it will seem as though they have high flow efficiency. This is one of the many reasons why there is no one metric to rule them all, no matter how attractive they may seem. Always cross-check and investigate using other charts to avoid falling into this trap. Suppose your team's flow efficiency is consistently below 40% and you want to investigate why. You use the aging work in progress chart and the heat map to discern that most waiting occurs in the in review status. To combat this, you decide to add more reviewers, automate notifications for review requests, and limit the number of items in review at any time. After implementing these changes, you see flow efficiency rise to 50%, and your average cycle time drops. This is one of the many ways you can use these charts to turn insights actionable. To close with some best practices, make flow efficiency a regular part of your team's retrospective or continuous improvement process and investigate low efficiency by using this chart and others to identify and address bottlenecks or process waste. Limit work in progress as too much WIP often leads to lower flow efficiency. Track trends, look for improvements or declines over time to measure the impact of process changes. We hope you enjoyed this look at the flow efficiency chart. Please feel free to reach out to us via our support portal or by email at support@55degrees.se.